to pay back the energy invest for using solar product in that area. Normally, the payback period for a multi-crystalline silicon photovoltaic system is more than a year. Thin film solar cells have shorter energy payback period compared to multi-crystalline silicon cells because they are much cheaper. For example, cadmium telluride cells have a payback period from 10 to 22 months. Price race. The industry has a long pursued target to making solar generation electricity to be as cheap as $1 per watt by the year of 2012. This falling of cost is due to better cell efficiency and improvements in manufacturing. Also, contract purchase of electricity generated by rooftop panels over 20 or 25 years result in a predictable and lower costs. In the past, due to supply deficiency, the price has been relatively high for years, but this will change in the future. Now let's look particularly at the cost for photovoltaics. In photovoltaics, solar value is added up from the cost of sand raw silicon to the completed solar module, and further on the cost of photovoltaic system promotion and installation. There's a company called First Solar claiming that within 5 years its thin film solar cell could compete with coal. And this diagram shows the structure of their thin film solar cell product. Their product has these cost benefits. The lighting area has been scaled up from postage stamp to traffic sign dimensions, and its active elements is just a hundredth of the thickness of the old standby silicon. It is built on a glass substrate, which enables the production of large panels. Its manufacturing only takes just 2.5 hours, and it can last for 25 years and will be returned for recycling. Research that has been done shows that compared to other energy sources, the use of solar energy system has much less energy consumption on a scale of equivalent CO2 consumption. This graph compares greenhouse gases used for using different energy systems, and we can see for coal and oil it's really high and goes up to nearly 1,000, but compared to that, solar using photovoltaics is only takes 13, 37 and 18, and just a little bit more than wind. Now let's go to a case study to see how solar energy industry has rapidly developed during recent years. Let's take China for example. First, some highlights. By the year of 2030, solar energy generated power will take up to over 10% of total global power supply. And China has become known as one of the world's largest solar energy production bases. China will receive about 23% of global investment related to renewable energy between the year of 2005 and 2030, equivalent to about 1.2 trillion. As a byproduct of rapidly developed solar energy industry, China now becomes the world's biggest solar water heater producer and consumer. Both its output and consumption of solar water heater account for over 50% of the world's total volume, considering the large population in China. Research shows that 58.25% of Chinese households are willing to use solar and water heaters within the next 5 years. As you can see, there are solar panels all over the top of apartment buildings, and it's a $8.77 billion US potential market. Now I'm going to show some interesting facts from a company called Haiming Solar Energy Group, which is the world's largest manufacturing basis of solar thermal products. This company have totally promoted solar energy equivalently up to 7 to 8 years amount of European Union and 16 to 18 years of amount of North America. They have 50 fully automated product lines, more than 300 specially designed equipment in solar application. They have built the world's first and only solar museum. This museum has objectively recorded solar energy development and justly prioritized solar energy's contribution in human developing history, such as simple solar utilization in ancient times, solar energy's developing course, advanced solar technology in China and the world. It provides blueprint for energy's utilization in the future, transferring electricity power from west to east, desert treatment, seawater desalination, and other projects, all of which will be returned into reality depending on solar energy. They have also built the world's longest solar PV lighting street in the world. The PV lighting road, about 10,000 meters long, is the world's longest national highway illuminated by solar lamps. The lamps have more than 5 different designs, and the LED lights outlining the battery borders have drawn a beautiful scenery along the highway. In addition, there is a park nearby with area of 1.2 million meters square, adopts many kinds of solar lamps to light the park. They are now building the world's largest solar architecture, the International Renewable Energy Communication Center. The International Conference Communication Center is a public architecture joining exhibition, scientific research, office, meeting,